Okay, so today we're doing Module 6, Lesson 4, where we're talking about dividing fractions and whole numbers. So this one is going to be similar, okay? We're doing the opposite. We did multiplication of fractions the past 3 days, but today we're starting dividing fractions and whole numbers, okay? So uh, I'm going to use fractions here. You can follow along, okay? Stop, please. Stop, please. I hear talking still. Okay, so Mia walks a 2-mile fitness trail. He stops to exercise every 1/5 of a mile. How many times does Mia stop to exercise? So I'm going to draw a number line, which is already done for me, okay, from 0 to 2. And then I'm going to divide that number line into fifths, which is already done for you, okay? And now I need to label each of my fifths on my number line. So that means I have 1/5, 2/5, 3/5, 4/5. So I have 1/5, 2/5, 3/5, 4/5. Okay. This is 1 in that number. If you would like to write ones in front of them, you can. So, she stops every 1/5 of a mile. That means every time she stops, I'm going to count. So, she stops here. Stops here. She's going to keep stopping every single 1/5 of a mile. Okay, that's what I'm doing. Every time. She's stopping every single time that she hits a 1/5 of a mile. So how many fifths are in my 2 holes? How many fifths are there? I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there are 10 1/5 in 2 holes. So I can use the relationship between multiplication and division to explain my solution. So 2 divided by 1/5 is equal to 10 because 10 times 1/5 is equal to 2. So we already did this, right? We've already started this. We've done the multiplication part, right? So we're doing the opposite. So think about whenever we did, the past couple days, right? So whenever I multiplied, right? Whenever I multiplied, did I end up with a number greater than or less than the number that I started with? Whenever I multiplied. Peyton. Not whenever I multiplied. The number was what? It was less than, wasn't it? Was it or was it greater? No, it was less than. Okay. Whenever I multiplied, so look, see, whenever I multiplied 10 times 1/5, I ended up with 2, right? So this number is less than, right? My product is less than the original number. However, whenever I divide, mind you, this is starting with a whole number. Remember, division doesn't work the same way as multiplication. Multiplication, I can swap my numbers around, right? And it doesn't change the product. But whenever I divide, it does change. Okay, so today we are starting by talking about starting with a whole number. Okay, there is a difference between starting with a whole number when I divide and whenever I start with the fraction. Do we understand that? I feel like there is nobody paying attention to me right now. Okay, well, whenever you talk, that shows me that you're not paying attention. Okay, so that means that she stopped 10 total times during her exercise. So Roger has 2 yards of string. He cuts the string into pieces that are 1/3 yards long. How many pieces of string does Roger have? So just like, I'm going to draw it out because I really don't want to pull up the fraction strips. Okay, so I have two holes, right? So he cuts this 2 yards of string into pieces that are 1/3 yard long. So how many thirds are in one hole? How many thirds are in one hole? 3, right? Think about, oh, my numerator has to be equal to my denominator. So I have 3/3 in one hole. Okay? So that means, how many strips are there total? How many strips are there total? If I have 3 for every one, how many total thirds are in two holes? Lexi. Well, no, it's just 6, right? It's just 6. Don't overthink it. It's literally just that there are 6/3, okay? So that means 2 divided by a third is equal to 6, because 6 times a third would give me 2. It's the opposite. So that means that there are 6 pieces of string. So I'm showing it through some models. In just a moment, we're going to walk through a anchor chart that shows you exactly what's happening, okay? Because this is super, super duper important. And frankly, the math makes more sense when you do it the way that I do it, okay? Whoops. Excuse me. So, I know I can use fraction strips to divide a fraction by a whole number, right? So, Talia shares half of a package of clay equally among herself and each of her 2 friends. What fraction of the whole package will each friend get? So I already have my half a strip, right? And I need to divide that equally into 3 people because there's 3 people that are getting this clay, right? So each piece right here is going to be what? 1/3? Well, remember 1/3, what does that look like compared to this one whole? This is 1/3. Does that make sense? No, one group is not going to have 1/3. What else do you think? Let's think about it. You can think about your fraction strips. You can kind of start playing around with them if you want to see what would be equivalent to 1/2. I can check some different things, right? I have 1/2, right? Would fifths match up equally? No, because they're an odd number, right? It's kind of like the common denominator stuff, right? I have to find a common denominator that's going to fit equally into 3 underneath there, right? What would be a realistic thing to put underneath there? Oh, I heard somebody say it. What do you think? Let's check. Look, you're exactly right. So each piece, so this one right here, so find the 3 fraction strips with all of the same denominator that fit exactly underneath the 1/2 strip. So each piece is 1/6 of the whole, right? Nope. So 1/2 divided by 3 gives me 1/6. Because 1/6 times 3 gives me a half. Are you seeing any relationship between my numbers? Look at the numbers themselves. So look, I have a 2, I have a 3, I have a 6. What's the relationship between 2, 3, and 6? Lexi. Oh, okay. So 2 times 3 gets me 6. Okay, that's some good information to know. So let me look back over here. I want to look at these. What do you notice about this one right here? 2, 5, and 10. How are those related? How are 2, 5, and 10 related? Ladies. 2, 5, and 10 related. How are they related? Bryce. I multiplied 2 times 5 to get 10. I also have something in common. So whenever I started with a whole number, but whenever I divided, I ended with a what? What? A whole number, right? So whenever I divide, I start with a whole number, I end with a what? Whole number. Every single time. When I start with a fraction, however, if I start and I divide a fraction by a whole number, I end with a fraction. And there's this lovely, lovely thing that I am so blessed to be able to talk to you about is this. I'm going to show you on the anchor chart in just a second on how exactly the math works. Okay. But let's look at some of these model examples first before we go further because you do need to know the model version. Okay. So I see 3 divided by a third, right? So how many thirds are there? 1, 2, 3, 4, 5, 6, 7, 8, 9. 3 times 3 is 9. Because 9 times a third gives me 3. Do you see how they're related? Yeah. Because they are the inverse operation, so they are related. Okay? But whenever I divide, I get the bigger number. But whenever I multiply, my product is a smaller number. Okay? So then, this one right here, 3 divided by 1/6. So what would be on each of these tick marks right here? What would be on each of these tick marks? Oh, not, what is this? What is it? Look at this board. Look at your paper. What does it say? So I'm not gonna write all of them, but oops, I did. It's 1, 6, 2, 6. Then you keep going, right? And then you would mark all the way up, right? But that's equal to doing what? You just need to do what? What am I gonna do? I'm gonna multiply 3 times 6 to get that number, right? So 3 times 6 is what? 18, because 18 times a 6 gives me 3. I like that it shows this and this because it shows you both operations. So you've already done this, right? You've already been doing this the past few days. But now you're seeing the opposite, the inverse, being represented because this works. Because I know already that this multiplies to get this, I can look back and I can see the reverse, the inverse, right, happening with my division. Okay, so I have one whole, right? This is just for reference, okay? But now I'm starting with a fraction. So I start with a fraction and I divide it by 2 and I get what? What am I going to get? Is it going to be a whole number or a fraction? What did I say? I start with a fraction, I end with a fraction. And what is it displayed right there? 1/8. So if you didn't notice, the types of fractions we're working with, they're called unit fractions. So a unit fraction is any fraction that has a 1 as the numerator. Okay? So I'm using specifically unit fractions with this division. Okay? I'm only using unit fractions. Do you understand that? I'm only using numerators with a 1, which is a unit fraction. So then, I know that 1/8 times 2 equals 1/4. Yes, sir. What? Yes, but it's because 1/4 has been divided by 2. 1/4 is split into 2, and so then there's 8. Okay. This represents, hey, look, let's talk about it. 1/4 is the number I'm starting with. The fact that there are 2 things here is the 2 that I'm dividing it by. So therefore, 1/8 is what I get. Because 1/8 is the part of the 2 that I divided into. Like up here. So look up here. This one wasn't confusing, Grayson, was it? This one wasn't as confusing, right? Because you know that this right here represents my answer. One of them. One of these represents my answer. Because it's just split into the 2. That's all. Don't think about it. Don't overcomplicate, okay? So let's talk about 7 through 9 here real quick. So ants are lined up along the edges of your sandwich at a picnic. If the sandwich is 9 inches around and each ant is 1/6 of an inch, how many ants are lined up around the sandwich? So I need to do what? Am I going to do 9 divided by 1/6 or 1/6 divided by 9? So I have a sandwich, right? And there are ants that are lined up on the edges. So there's little ants. What am I going to do? I'm going to do 9 divided by 1/6. Why do I look at my answer choices and what do I notice? Peyton, they're whole numbers. So can I automatically know what operation I'm doing and how to set it up? Yes. I know that I'm doing 9 divided by 1/6 because I start with a whole number and end with a what? Whole number. So remember, these two numbers are really being multiplied together. So 9 times 6 is what? 9 times 6 is what? 54. That is my answer. So I'm going to show you something real cool, and I'm going to represent it on an anchor chart in just a second. So what I do, whenever I divide by a fraction, I'm going to do what's called, I keep my first number, I switch my operation, and I flip to the reciprocal. So instead of 1/6, I write 6 over 1, which is also equivalent to 6. Now, I have 9 times 6, which is 54. That's how I'm getting my number. Do you see that? Are we following along or are we playing with our fraction strips? I hope you're following along. Did you see how I did that? I keep my first number, I switch my operation, and I flip my fraction to the inverse. Not the inverse, the reciprocal. Okay? So, which is the division problem modeled in the picture? So, remember, this is the type of question you're going to get asked on your cumulative test next week. Okay? It's asking you to look at the model and see what what's represented. I'm not having to represent it myself. I'm having to recognize the model. So first of all, I see that there are how many poles? 3. So what can I do? I can eliminate something. What can I eliminate? Peyton. D. What else can I eliminate? Elizabeth. A. Okay. I am dividing 3. by a fraction of some kind. What am I dividing 3 by? What's the fraction there that's listed? Not 3, it's what? What's this? 1/3. Okay? I'm dividing 3 by 1/3. My answer is C. If this said 1/4 in there, then it would be 3 divided by a 4. Okay? Let's see this one. I thought this one's a little bit easier to recognize in a model. It's just the top strips. At least whenever you have the, I'm probably going to go over some of the work page with y'all just so that we practice a little bit of the models. Okay? So I have 3 wholes divided by a third. That one's simple. The other one you see is the one that we just did on number 3 over here, right? So this one, I have 1/4 is the one that I'm starting with, right? And then I'm dividing it into the pieces, which is 2, right? There's 2 pieces. And my result is an 8. Okay? So look, Maddie divided 6 by a half. And then divided that answer by a third. So first of all, I need to figure out what 6 divided by a half is. So remember, 6 divided by a half, so I switch flip. I keep my 6, I multiply by the reciprocal, which is what? What's the reciprocal? 2. So I have 6 times 2 is what? 12. Now it says that I need to divide that answer by a third. So 12 divided by a third. So now I do the same thing. I keep my 12, I switch my operation, and I flip it to 3. 12 times 3 is what? 36. No, I want to look at something. Okay? So look. I want to look at 3 and 5 over here so we understand it. Okay? So look. 1/3. That's my starting number. So if I didn't have this information here, I would start with a third. And I know I'm dividing it by how many pieces? How many pieces are there? Grayson? 2. So then my answer is what? What? What is my answer? It's one of these. What does it say? 1/6. 1/6. That's all. I promise it's not that complicated. So you write 1/6 on those 2 lines. Okay? Same thing here. I have 1/5 and I'm dividing it by how many pieces? 2. And that gives me what? 1/10. Because same thing. I would keep this, I would switch the operation, and I would flip this to 1/2. And because the 2 denominators, I can multiply the 2 denominators together. Okay? Do we understand that?
Yes, I do.
So let's make an anchor chart on how this works real quick. Okay? You need your math spiral out. Get it out. I'm writing dividing fractions and whole numbers. Good. Where you get a comic mark. So you might need a few colors. Okay?
You have the colors or no?
I would prefer you use colors. So we are going to do two different ones. So you are going to need to split your paper kind of in half, okay? About here. Okay. So I'm gonna just the one that I pulled up, it has a word problem, but I'm just gonna do the actual whatchamacallit, the actual problem. So I'm going to write divide a whole number by a fraction.
You can't see my little. I thought you kind of did.
Yes. Divide a whole number by a fraction. So I'm gonna split it because I'm gonna do a model on one side and the key switch flip on the other. So I model. So I'm going to divide 4 divided by 1/3. Okay. So I'm gonna do this one on a number line.
It's Latin phrase between 1932 graphic.
Okay.
Because is, do you know if you like the video with the screen return blue?